Okay. Yesterday we have talked about how to sketch for exponential equations, and today we're going to talk about how to solve exponential equations. For this chapter, we basically talk about how to solve and sketch exponential and exponential and logarithms. So yesterday we have learned how to sketch these graphs. So just have a little bit of review on that. We first of all draw the horizontal asymptotes, which is the C value, and then we pick a starting graph. Either can be an increasing one or a decreasing one, depends on the A value. If A greater than 1, what's going to happen? If A is in between 0 and 1, what will happen? And also your base can't be negative, because for some value you can't find a value, for example, -3 to the power of half, like you can't evaluate those values. After we pick a starting graph, we think about two reflections. Do we have horizontal reflection, which is the capital A less than 0? Do we have vertical reflection when is the K is negative? And then after the reflection, we find the final shape, and I know what's the shape of the graph, and we find x-intercept if possible, and we definitely will have y-intercept. And if we only have one intercept, then we need another point, because we need 2 points labeled for one graph, because two graphs can show the dilation. For example, if I said I pass through this point, well, this exponential can pass through this point. This exponential can also pass through that point, like it's not really enough information. So we kind of draw 2 points and can show the dilation, which one you prefer, like which one is the one you actually sketch. That's what we learned yesterday. And today we're going to talk about 13D, which is solving exponential equations and inequalities. Okay, we're solving equations and inequalities. So for this exercise, when we solve for exponential equation and inequalities, we can make both sides to have the same base. Okay, that's the key idea for this exercise. We will have situation cannot have the same base later. After we learn log, we'll learn what we will do when we have like different base on each side. For example, 3 to the power of x equals to 4 to the power of something. So we learned this in year 10 already. So if we have a to the power of m equals to a to the power of n, the only situation these two numbers can be the same is m equals to n. Okay, when two numbers are the same and they have the same base, they must have the equal power. Okay, so 4 to the power of something equals to 4 to the power of something. The power must be the same. So what we need to do is we're trying to make both sides to have the same base. Okay, we make both sides to have the same base. So if we see this one, 4 to the power of x equals to 256, we can see 256 can be divisible by 4. So we divide that by 4. We can see that's 24 and 16, and we have another 4, 64. So we have 4 times 64. 64 is 4 times 16. And 16 is 4 times 4. Okay, so what we have is 4 to the power of x equals to 4 to the power of 4. So I change 256 into 4 to the power of 4. And I have x equals to 4. And I have x equals to 4. So base are the same now, 4 equals to 4, and then power must be the same, so x must be 4. Okay, the second one. 5. Okay, you can see one side base is 5, the other side base is 25, and they can both become base 5. So 5 to the power of 2x minus 4 equals to 5 to the power of 2 to the power of minus x plus 2. Okay, make that into the same base. So 5 to x minus 4 equals to 5 to the power of minus 2x plus 4. Okay, times 2 with minus x plus 4, so it's minus 2x plus 4. Therefore, when bases are the same, you can make the power to be the same. So we have 4x equals to 8, and x is 2. And x is 2. Well, let's have a look at the next one. Okay, this one. Well, for equation solving, I can make this both sides to be base 2. I can also make both sides to be base 1/2. Yeah, like 2.5 is possible, like it's just power of -1. So if I want to make it if I want to make both sides to be power of 1/2, base of 1/2. So what I can do here is 2 to the power of -1 and then to the power of 3x. And this side is 1 over 2 to 64 is 8 times 8. In each 8 there are 3 2's, so there are 2 8's, so 6 2's. So it's 8 times 8, 2 times 2 to the power of 3, 2 to the power of 3. So what I can write on this side is 1/2 to the power of 3x. On this side, I can say that's 1/2 to the power of 6. So 1 to the power of 6 over 2 to the power of 6. That's 1 over 2 to the power of 6. I will say 3x equals to 6 and x equals to 2. Or I can also make it into that's 2 to the power of -6. I can make both sides to be base 2. Okay, that's 2 to the power of -6. And you will have -3x equals to -6 and x equals to 2 as well. Okay, when we solve equations, what base I make, it doesn't really matter. Okay, I can make base to 1/2 or I can make it base to 2. So for this question, I can make base of 5. I can also make it to base of 1 over 5. Okay, so I can make to base A, I can also make it to base 1 over A. So well, A is a number larger than 1 and 1 over A can be a number in between 0 to 1. But both of that will work. Okay, let's give example 2 first because it's not really similar to the previous one. Let's have a look at inequality. Okay, after solving equations, let's think about inequality. I want to choose a similar one first. Okay, I want to choose this one. According to the case I tell you above, I can make it into base 1/2. I can also make both sides to be base of 2. Okay, let's have a look what will happen if I make different things. So let's make it to base of 2 first. That's 2 to the power of -3x plus 1 less than, well, 16 is 2 to the power of 4. 4 times 4 is 16. So that's 2 to the power of -4. If I make into base 1/2, that's 1/2 to the power of that's a half. Okay, so that's 2 to the power of -1, and then that's 3x minus 1, less than a half to the power of 4, and that's a half to the power of 3x minus 1, less than a half to the power of 4. So if you think about the left-hand side, I will solve for that. Do not copy what I write now. Okay. Just look at my solutions. It's alright. If you copy that one, that's fine. Don't copy the other one. That's according to this, what I solve, okay? According to base of a half, if I do the same thing, what do you realize? It's different answer. Okay, why we have different answer? Well, solve equation, I use two methods. I have the same answer. But solve inequality, do the same thing. And we have different answer. It's the sign flip. Okay, the sign changed. Answers do the same, like just the sign point different directions. What do you think it might go wrong here? Or say which answer is wrong? How do you check? If I want you to check which one is correct, like how you can check it? Okay, what do you substitute? 1? Or you can sub anything and you see which set contain that number. So if we sub 1, okay, if we sub 1, that's 2 to the power of minus 2. If you sub 1, that's 2 to the power of minus 2. And then that's 1 over 4 and 1 over 16. Which one is smaller? So sign should be like that. So is that satisfied? X equals to 1, alright or not alright? No. Okay, so 1 shouldn't be the answer. So which one is the incorrect answer? This one or this one? Which set contains 1? The second one. Okay, the second one contains 1. So this one is incorrect. Okay, the other one will be correct. But why is like that? Well, you can't solve inequality and every time you need to check whether the answer is correct or not correct. Think about two graphs. What's 2 to the power of x looks like? And what's a half to the power of x looks like? Can you sketch those two graphs? What's 2 to the power of x looks like? And what's a half to the power of x looks like? That's the most basic graph, okay? So it's the first step. After you sketch the graph, can you tell me what's wrong? What's 2 to the power of x looks like? Increasing, decreasing? Increasing? Okay, what's a half to the power of x looks like? Okay, for a half to the power of x, a larger number will give you a larger value or a smaller value. A larger power will give you a larger value or a smaller value overall. Look at your graph. What decreasing graph means? What is x? What is x? What is called? Power. X is the power, okay? So your power is changing. So This diagram is showing you how the power change and the y value change. So that's y equals to half to the power of x. A larger power will give you a larger y value or smaller y value. Smaller. Okay, a larger power give you a smaller y value. For example, you sub 2, you get a quarter. You sub 3, that give you 1/8. Okay, a larger power will give you a smaller value. That's the decreasing function means. Okay, x increase, your y will decrease. But for 2 to the power of x, your power increase, your y value will increase at the same time. So that's what went wrong here. Okay, that's why it's wrong here. You want a smaller overall value for the left-hand side, which means you don't need this sign is still smaller, but here is wrong. Here you need a larger power for the left-hand side. Okay, the sign is wrong. Okay, all the signs should be pointing that way because you want this number to be smaller than this number. Then this power needs to be larger than 4, not smaller than 4, because only a larger number will give you a smaller y value when base is in between 0 to 1. Okay, when base is in between 0 to 1. So that's why we have different answers. But now if we change the direction, I can see we get the same value here. Okay, we get the same set of values here. You need to consider from the shape of the graph. Because you have two different shapes, you want one number to be larger than the other one. Now you need to compare the power. It's not always a larger power will give you a larger y value. Sometimes, like when the base in between 0 to 1, you will have a larger power, but you have a smaller y value overall because the function is decreasing. Okay, because the function is decreasing. So after this question, what I want to say is, we need to make base greater than 1. Okay, we need to, I can make base to be 2. I can also make base to be a half. So when I make the base to be something, I make it to be greater than 1. That's possible to achieve. And then all the sign will be the same direction. The power larger, then the y value will be larger. So you don't need to think about the sign change when you have a base greater than 1. So that's what I want to show you in this exercise. Okay. So when you solve equations, it doesn't matter. It doesn't matter you have a base of a half or base of 2. Same base will give you a same base, same power, give you the same y value. But for inequality, you need something to be larger than something. Then the power needs to be compared as well. So that's why we want to compare it correctly. Therefore, I will suggest you to make every base to be greater than 1, not in between 0 to 1. If you make a base in between 0 to 1, you need to think about the sign change. Okay, you need to think about the sign change. You want a larger number, then the base needs to be smaller. Okay, if you think about this one, okay, this one, base 3 definitely works. That's 3 to the power of 2, then to the power of minus 2x plus 8. Needs to be larger than minus 4x plus 16. Okay, base 3, base 2, or this one. This one will be 3 to, if you can't make it into the same step, you're not familiar with it, I would say that's a third to the power of minus 4x plus 2 first, less than or equals to 3 to the power of 3. And then 3 1 over 3, that's 3 to the power of negative 1. That's 3 to the power of 4x minus 2. So 4x minus 2 less than or equals to 3. So x is less than or equals to 5 over 4. Okay, if you can't convert things like directly, go step by step. Okay, be careful with the sign. When you negative the power, you need to negative the whole power. So every single term needs to be times by negative 1. So just be careful with that. Okay. If you can go up to have a look at example 2. Okay, have a look at example 2. If you look at example 2, you can see, well, what you can see is 9 to the power of x and 3 to the power of x. I'll just look at the variables. Okay, so 3 to the power of x and 9 to the power of x. The first thing you need to realize is I can't solve something contains 3 to the power of x and also 9 to the power of x. So I want to make they all looks the same. The thing contained the variable looks the same. So 9 to the power of x, 9 can be 3 times 3, and then to the power of x. So what I have here is 3 to the power of x times 3 to the power of x. So I make they all look the same. 3 to the power of x times 3 to the power of x equals to 12 times 3 to the power of x minus 27. This is not really exponential equation because I can't make both sides to be the same. They also contain constant, they contain the 12 times that. I can't make them to be the same base. There's no way to do that. So the first thing is at least I want to make them all look the same. The thing contained the variable all looks the same. Now I can call change of variables. I want to change my variable. So I will let 3 to the power of x to be a. I change to another variable, like 3 to the power of x equals to something. They're all the same, like 3 to the power of x, they're all equals to one thing. So I make that equals to a. So what I will achieve is a times a equals to 12a minus 27. So I have a squared minus 12a plus 27 equals to 0. We have changed this into a quadratic. Okay, we have changed this question into a quadratic equation. What we'll have is a minus 3 and a minus 9. Okay, a minus 3 and a minus 9 equals to 0. Factorize it. So what I have is a equals to 3 or a equals to 9. And then I change my variable back. 3x equals to 3 or 3x equals to 9 because I still solve for x. Now the x is 1 and x is 2. That's how I solve for x. Let's think about this question. I know I just showed you how to solve for it, but like how you can recognize this is the type of questions you need to think in this method. Can you see this side? 9 to the power of x. I can also say that 3 to the power of x, then to the power of 2. I can also write that 3 to the power of x and then to the power of 2. When the variable, okay, when something contains two variables, and one of that is the square of the other one. Okay, so we have 3 to the power of x, and we have 3 to the power of x and squared. So one thing is the square of the other one. Then we need to change the variables. So I change that to a quadratic to solve. So that's how you can see. I'll just show you another one. It's nothing to do with exponential really. I can do like this. I'll show you this question. What do I need? I need a minus 27. You can see the two terms contain a variable. One is root x and one is the x. X is the square of the root x. Okay, so one variable is the square of the other term contains the variable. So this one is square root x and then squared. It's nothing really to do with exponential. It's just easy to see exponential. Like 9x is the square of 3x. But like I can also do just for normal like x. Okay, nothing to do with exponential. So now I can change the variable. I can change maybe that to b. So let root x equals to b. So b squared plus 6b minus 27 equals to 0. Factors to that. So what I have is b equals to negative 9 or b equals to 3. So it's not finished. Do not just change the variable and then not change it back. I also need to make b back to root x. So that means root x equals to minus 9 or root x equals to 3. What's the value for x? 9? How about the other one? $81? Square root 81 is what? Is that negative 9? No. So this is no solution for this one. Okay, it's rejected. Because your root x can never be negative value. Okay, you root something won't be negative, it only be positive. So we don't have this answer. So x can only be 9. You're not going to take all the values because when you change variable, it will increase, like there's no limitations. Because your root x will be only be positive. But when you change your root x into b, b can be anything. So you actually increase the possible set. And then you solve out negative 9 and 3. Yeah? No, I explained that before. No. Only when you say x squared equals to 81, your x will be plus minus root 81, and that case is plus minus 9. Root 81 is only a positive number. When you just say root 81, that's positive. You can never have negative for a root. It's when you're solving even powers, That's plus minus, because when you sub that back, it's minus 9 squared is still 81, but nothing to do with the root itself. Root is a positive. Okay, root is a positive. So root x, well, root something, remember the square root function, that needs to be a positive number, like or greater or equals to 0. The restriction is root x must be greater or equals to 0. So similarly, if in this question, well, I know the question is different. If in this question I solve out a is positive and a is another negative number, say we have 3 and negative 9 for this question. So if I have a equals to 3 and negative 9 for this one, so your 3 to the power of x equals to 3 and x equals to 1. This one is alright. But 3 to the power of x equals to negative 9. That will be undefined. Like you won't work out that because exponential is always positive. Like a to the power of x is always a positive number. So a positive number to any power will still be positive. So you won't have the negative. But like we don't have negative 9 in this question. But if you solve out negative, you need to reject it. Okay, you need to reject it. Okay, so this example shows us how to change your variables, in which case we need to change variables, and what answer we need to take or we need to reject. Sometimes we take both if it's positive, sometimes we only take the we reject the negative. Okay, if we have negative, sometimes we reject the negative. Combined with exponential. Okay, exponential is always positive. I think that's all for today. Because I think we have to remember logarithms anymore. Next page is about log functions. I want you to go through the laws again. I believe year 10 we all learned that last year. No log. There are a couple of rules. Just read through that if you can't remember them anymore.